Thunder cracks as energy is released into the world. A new radioactive superhero has the ability to save us from Earth's global energy crisis in shiny, silvery armor. Its superpower of providing unlimited energy will truly be an asset to our planet. A friend to the environment, this superhero has actually been around for longer than Earth's existence. Named after the Norse god of thunder, thorium is currently being hailed as the future of nuclear power, having the potential of becoming one of the world's most important elements. Hello, my name is Gabriella Fish, and today I will be discussing the element of thorium. Yes, you heard it here, thorium is the future of nuclear power. Positioned at the 90th spot of the periodic table, this radioactive metal is made up of 90 protons and 142 neutrons in its naturally occurring isotope, thorium-232, which I will be expanding on later. Thorium, the superhero, is a silvery white color, but tarnishes black and is a solid at room temperature. Now, before getting into the nitty-gritty details of the extent of thorium's potential, I must explain where the superhero originated. Thorium's story begins in 1815, when an unknown metal was discovered in the fallen copper mine in Sweden. This unknown metal was given to John Jacob Berzelius, a Swedish chemist, to discover its identity, as he had previously discovered both cerium and selenium. After analyzing the substance, he determined that this hidden substance must be a new element and dubbed it thorium after the Norse god of thunder. However, he was soon disproved as the element he had analyzed was actually just yttrium orthophosphate. Years later, in 1828, Morten Thrain Esmark, a Norwegian priest, found an unusual element in Telemark, Norway. He sent this element to his father, who was a chemistry professor, in order to see if he could find the hidden identity. Unsuccessful, Esmark's father then sent the element to Berzelius, who was able to correctly determine that this in fact was a new element. Because of this element's extreme power and radioactive nature, he proclaimed this new element as actually being thorium, giving the element its name and identity. However, even decades after its discovery, thorium was never given any practical uses. It was only in 1885 where it got its first use. Our superhero thorium got hired in its first official job, as a mantle for gas lamps. A mesh cloth bag filled with thorium oxide would be heated up and it would shine bright with a gas flame. The use of thorium in gas lanterns, however, soon came to a close because thorium turns into ash when heated, and that can be breathed in. So basically, thorium ended up getting sacked and replaced by its good old friend, yttrium. But no worries, the most important attribute of thorium was discovered in 1898. Gerhard Karl Schmidt and Marie Curie discovered that thorium was radioactive. This was an incredibly important discovery, as uranium was the only radioactive element until thorium's discovery. In the 1920s, thorium toothpaste was released. It was called Dormad Radioactive Toothpaste and was hailed as beneficial, for it was thought that its radioactivity increased the defense of teeth and gums. During World War II and the aftermath of the World War, people did not understand the harms of radioactivity, so they ingested it everywhere. Okay. Although thorium is radioactive, it's still considered to be a weak radioactive metal. This can be seen through its half-life, which is about 14.05 billion years. To put this in perspective, the age of the universe is thought to be about 14 billion years old. In fact, thorium is the element that brought to light and established the concept of a half-life. Typically, the shorter the half-life, the more radioactive an element. So, although thorium is radioactive, its half-life does demonstrate that it is very weak. Sounds like thorium will not be picking up Mjolnir anytime soon. Although thorium is not being used much at the moment, thorium has insane potential, as it has the ability to provide clean and unlimited energy to our whole planet. Now, in order to understand this, I must talk about another element. Thorium has a much more reactive, mischievous, problematic brother, only 2 steps away from him on the periodic table. Element 92, uranium, is currently the power source of all active power plants. It has 2 naturally occurring isotopes, uranium-238 and uranium-235. Uranium-235 takes up 0.7% of all uranium and is a fissile isotope. This means that when hit by a neutron, it releases 2 to 3 neutrons, which then hits more fissile isotopes, forming a chain reaction using nuclear fission. Uranium-238 makes up 99.3% of all uranium, and is a fertile isotope. This means that when hit by a neutron, uranium-238 will undergo a series of decays that then become plutonium-239, which is a fissile isotope, being used the same way as I described before. However, a big issue with uranium is that the enrichment process required to separate isotopes is extremely expensive and slow. Thorium provides a cheaper alternative, as it only has one naturally occurring isotope as described before, thorium-232, so it does not have to go through the grueling enrichment process. Thorium-232 is a fertile isotope, so when hit by a neutron, it becomes thorium-233, which is extremely unstable. This leads it to undergo two beta decays, which turns it into protactinium-233, and then uranium-233, which is a fissile isotope. So, this complicated chemical process basically means that thorium can be used for nuclear power. Okay, big deal! Now, why is this so important again? Well, not only is thorium a much more time and cost-efficient way of obtaining nuclear power, thorium is also way more abundant than uranium, there being 3 to 4 times more thorium than uranium on our planet. Additionally, thorium reactors would use a liquid fuel source rather than a gaseous one like uranium, meaning less waste would be produced than with the current uranium reactor. Thorium reactors will also be about 1,000 times less radioactive than a uranium reactor. Actually, thorium reactors will be so much safer than uranium reactors, as they can have built-in mechanisms that stop destruction in harmful events without a human present. This is because when overheated, plugs made of salt will allow the liquid, because thorium reactors are made of liquid, to drain into a tank that will stop the chain reaction of fissile isotopes. Because uranium reactors are gaseous, they cannot be stopped. So, it's been pretty much established that thorium is a much better alternative to the harmful uranium. So, why is uranium still the fan favorite? Well, simply, when nuclear reactors were being developed, there was much more information about uranium available. Additionally, uranium reactors released plutonium-239, which is a primary fuel for nuclear weapons, which was considered beneficial during the Cold War. Being much more safe and environmentally friendly, it would be practically impossible to create intense weaponry using a thorium reactor. So because plutonium was needed to create nuclear weapons, uranium was continued to be used. However, as there is more of an effort to keep this planet healthy, be more cost-efficient, and increase energy, thorium the superhero will soon trump uranium and play a massive role in energy production in the near future. Thank you so much. My name is Gabriella Fish, and this was my presentation on thorium.